All right, so again, you're going to have 10 definitions that we're going to write down and 3 rules that we're going to write down for this assignment about line convention. Line convention meaning the way that we do things. This is the convention way. Conventional way. See if I can expand this. All right, so lines of varying size and thickness are used in a specific way to develop and communicate graphic messages about an object's geometry. So all this is really about is how we draw things and how different lines have different meaning. That's the key part. Different lines have different meaning. So let me go through a couple of the basic ones here. So the first one is a construction line. A construction line is a very lightly drawn line, and it's used to guide drawing other lines and shapes. So I would kind of shorten that down. It's key that it's a light line, and its function is to guide your drawing. Those would be the key things to get down. And then I would draw a light line by it to show you, to remind yourself, a construction line is a very light line. So I would, what I would do for these notes is write something about what it looks like, write something about its function, and then draw a quick example. And you can see their example right here are very light lines. Nathan, line convention is just, let me see, I'll just go right back. It's not necessarily a definition you need to write down. Lines of varying style and thickness are used in a specific way to develop and communicate graphic messages about the object's geometry. It's kind of a little wordy for an easy definition. But I do want you to get these examples down. So light lines, it's guiding your drawing, and then draw a real light line. Just kind of show what a light line is. What I used to do is I used to print this out, and we would label them with the definitions too. So what I suggest is just kind of draw a very light line as an example. Second definition, an object line. This is a darker line, and its function is to define the object. It's the edges of the object. That's why it's called an object line. So just draw a darker line as an example of an object line. A hidden line. This is a dashed line. A dashed line, it's even spaced. So you could make a couple of dashes across to show what it is. A hidden line, a dashed line, like I said, and its function is to show detail that's not visible. To show detail that's not visible from the outside. If you notice in their example, we've got like a circle back here. It's dashed here because it's behind this and we can't see that kind of like recess on the back of it. And then it's kind of broken away on this side so that you can see a defined object line edge. This is like a little bracket. The bolts go down here and then something sits in here and rotates. So it kind of holds something in place. like a end of a crankshaft or something along that line. Everybody got down hidden line? Our next one is center line. Center line defines the center of arcs or circles or symmetrical parts. It's half as thick as an object line. You don't necessarily have to write that, but what it does is important. Now, the way that a center line looks like it has two different looks. You have the center line in the very middle of the part where it's a plus sign and it's got 4 long lines extending out from the plus sign. That's when you see it as a circle. I'm not sure how well I can get that up there. So see, it's a circle and it has a plus sign in the middle. And there's 4 lines coming out like a compass or like a scope. In a side view, like if it was a drilled hole, I put like the edges of an object and the sides are hidden lines, but the center line looks like this. It has like a minus sign in the middle and then 2 long whiskers going out. So there are 2 types of center lines. You have the profile that looks like this. Minus sign with 2 whiskers going out. That's the side view of a drilled hole or the side view of a peg. And then you have the profile view when it looks like a circle, when you're either looking at the end of a cylinder or looking at the end of a hole. It's a plus sign with the 4 lines going out. So that would be the 2 examples I would get down. Everybody ready to go to the next one? All right. Section lines. Section lines define where the material is cut away. Now, it's for the sketch only. So this object here that's kind of been referenced each time, it's not like it has a broken part intentional. It's broken away just for the drawing so that the person making the part gets to see some features on the inside to help them know how to make it. You might see that in magazines where something similar to that, where like maybe they show a house and part of it's broken away and you can see inside the walls, and you can see the pipes, and you can see the people like they're washing their hands in the sink and you can see the water going down the drain. And it's trying to show you like how things connect on the inside that you can't see in your house. Or maybe you've seen it in a car magazine where they have the hood broken away and you know the hood's not really broken, but it's broken away in the illustration so you can see on the inside. Or maybe part of the motor's broken away so you can see the pistons moving up and down and the explosions. It's not physically broken, it's just for the illustration. And it's the same thing here. Now, if you were to physically cut something and then break it off, it would look something like this. It would have sawtooth marks, and that's what these diagonal lines are representing, and they're called section lines. So if you see a bunch of diagonal lines in a row, that means that this was broken away it was cut away, and then you can see the tear line here. This jagged line here will be, I think the next one, a short break line. So the section lines are those diagonal lines. I ended up kind of just drawing a little kind of corner of this on mine to kind of show the diagonal lines. And they're to represent that the part has been torn away. I usually see them just like this. It used to be in engineering that every different material had a different section line look. Like aluminum looked different from steel, and steel looked, you know, different from copper, and different woods had different cut lines. But I think it's pretty much just standard that they're all diagonal lines now, and then the material is just labeled. At least that's the way I've noticed it on the computer program, not to have any distinguishing looks. So I'll give you like a little extra minute to kind of draw a small example for your notes. All right, so that jagged line there is the short break line. It shows where the part is broken to reveal detail behind the part or to shorten a long continuous part. So it's kind of the boundary line between where the illustration was cut away and where it's normal. All right, the next two, they kind of go hand in hand. So I would recommend drawing like one example, and then in your definitions, like maybe putting arrows in between. And that is a dimension line and an extension line. So you might often call these dimensions, but by definition, the dimension is the part between the arrows here. This is the dimension line. And the extension line extends from the object to the dimension line. So it's kind of like this thin lines that show this part to this dimension line. So the function of the dimension line is obviously to show the distance. And what makes it a dimension line is that it has the two arrows with the dimension in between, or the number. It's typically located in the middle. I think that's kind of obvious, so no need to necessarily write that down. That's how most dimensions are. Sometimes they're shifted to the side if there's no space, but they're typically right in the middle. And again, the definition of it is to show the distance, and it's the arrows with the actual value. So with the same definition, or with the same illustration there, extension lines, these are a thinner line, and they extend from the object to the dimension. So it's pretty straightforward. That's why they're called extension lines. They extend from the object to the dimension. If you notice, there is a small gap, and it's usually regulated to be about a 1/16 of an inch. If you're using a computer program, all that type of stuff is generally formatted in there automatically for you. If you were to do it by hand, you'd always keep that gap. If you don't have that gap, it kind of creates some issues with your eyes, where it's kind of hard to tell where the object ends and the dimensions end, and can make it a little bit hard to see the geometry of the part. So there's always that gap there. I'll give you a minute to get the last part of that down. All right, got about 3 more definitions. This is a long break line. It's this really jagged part over here, this kind of lightning bolt, double lightning bolt. This is called a long break line. It's just short and a very long object that has uniform detail. So if you notice, this is like a little pipe with a flange at the end, and the flange is 1 1/4 in length, and then it says the rest of it is 12 inches in length. Well, if that's 1 1/4, then this does not represent 12 inches. This is cut so that we don't have to see the full length of the part, because it's all just like this long, almost 11-inch pipe. So we don't need to show the full thing on the paper. you just kind of do a long break line and shorten it. It's not uncommon for there also be like a little jagged break on the dimension, if I remember right. You'll see this also like in math classes. Sometimes they'll put the little jagged lines on like the y and x axis. If like all the data is like far away from the origin, they might put like a little break line on there to show the data kind of in a viewable window. It's the same kind of idea. So it's for something of uniform thickness, and you're trying to fit it all on the paper nicely. You might have to do like a quick drawing of that with the break line in it. And the next example is here's a leader line. This is supposed to be the other end of the pipe, like looking down it, so that we can show the diameters. And this is where you'll often see leader lines will be to show like the diameter or the radius of an object. So a leader line shows the dimension of the arc, circles, and it can also be used to show details, such as like a little note that maybe will point out something unusual to how to make this part or something unusual about the feature. A lot of times it's used to just show this is the diameter or this is the radius of the arc, or the depth of the hole. If you look at the other side, this hole right here only goes in half an inch. So it's saying right there, it's half an inch deep. So it's used to make little notes like that. And that is a leader line. It's like a one arrow dimension line. right, and now the last bit are some rules. So these are kind of the standards that you use when sketching. So as parts get more complex, so it might require a different line type to overlap, where some features are, in the same plane of looking. Certain line precedents must be used. And these are rules that govern line precedents in sketching and technical drawings. Can someone tell me what precedence means? Well, let me give you a bit of a story to help you see precedence. So there's this unusual intersection, and in this intersection, it's got a railroad going right through the middle of it. So coming to this intersection, there is a train at full speed. Coming to this intersection at green lights are also a postal worker, an ambulance with the lights on, a police officer with the lights on, and a fire truck with the lights on. Who is allowed to go first? Who has the precedence?
The first responders.
First responders? Technically, yes. Okay, so do they stop and figure out who's going to the most important accident and who's going to the most important emergency? But all of those people are first responders, with the exception of the post office worker and the train. Those other three are first responders. So saying the first responder goes first doesn't really make a deciding vote either. There has to be an order of things. And that's kind of what precedence has to do with, is the order of things are done.
Shouldn't the firefighter go first, and then after that the police officer, and then after that the ambulance?
Maybe. You kind of go
by the ambulance going last.
The ambulance would go last. The ambulance would be last. That's true. Why? Because
if it's a fire, then the firefighter needs to get there first.
Okay, the firefighter should get there before the ambulance. But you guys are missing something really important. Trains do not stop easily.
I said that earlier, sir. I was like, the train needs to go first because the train can't stop.
Because the train can't stop. It might take a mile or two for that thing to come to a halt, and then it's going to be completely blocking the intersection. So by the precedence of the laws of physics, the train has to go first. There's just no stopping that thing. So that has to go through first. After the train goes through, technically, if the postman has a green light, the postman should go first, because the postman is part of the federal government. I doubt a postman would do such a thing. They would probably stop and not be all like that. After that, it should be the police officer, then the firefighter, then the ambulance. And the ambulance goes last because the ambulance is actually a private company, a company for profit. The firefighters and the police officers are part of, the city infrastructure, and they're there for emergencies. Most often, these three are going to the same place. Usually, police officers or firefighters are the ones that get there before the ambulance. It just always depends on who gets called first. But it's really often that the police are there at the beginning. Firefighters are typically close to the beginning too. Sometimes it just depends on who is the closest to the issue that might come out and respond. But if they were all there at the same place, that would be the precedence, the order of things to come, of how it should be. So just as the same in this example, when you have items that are kind of lined up in the same location, depending on how you have the part oriented, object lines would take precedence over hidden lines, because remember, hidden lines and center lines. Those are things that can't be seen from where you're looking. They're hidden, right? That means there's probably another view that shows them off better anyways. So you should focus on keeping the outside of the part drawn more than the inside, or a marking of a center. So object lines take precedence over hidden lines or center lines. Hidden lines would take precedence over center lines, because a hidden line is actually a physical edge, if you will. A center line is just the middle of, many times, either the middle of the material or the middle of a hole. It doesn't physically exist. It's empty space or filled material. So it's not an edge, which is more important to know. A cutting plane line, like those short break lines or something like that, a cutting plane line takes precedence over all other things. So it's meant to kind of cut away a part for, purposes of the sketch to show internal details. So that would go on top of everything anyways. So that would be some line precedence. So here's an example. This part, it has a hole, and directly above the hole is like a little rut. And to the side of the hole is a little step. So in the top view, we can see the center line going through the middle of the hole, and which is also the middle of the rut. But because the object lines of this little rut or slot here, they line up with the ends of the hole here, you wouldn't be able to show the hidden lines, because object lines have precedence over hidden lines. If I look at this side view here, this center line lines up with this step. It's an object line. So the object line would take precedence over the center line. You can still see the center line kind of sticking out from the outside a little bit, because center lines actually go outside of the part when marking it, as it's also shown here. So you can still kind of tell something is there, but the majority of the center line is covered by that object line. So those are some examples of line precedence. So that's the end of the slides for today. If there was anything that you missed writing, of course, you can come back and look at these slides here. And you're gonna submit the pictures of your notes, whatever notes that you got down. It is 10 definitions with some basic illustrations, and then those 3 precedence rules. And you'll upload that on this right here.
Sir, you're not going to be able to read mine.
Why not?